All right, let's dive into something that's pretty scary and honestly a super sneaky threat in the AI world. It's less likely, but when it happens, impact can be catastrophic. Today we are talking about MCP session hijack. And this isn't just someone, peeking over your shoulder. We are talking about an attacker literally become your trusted AI agent. And that's the thing you really got to wrap your head around. It's not just a simple impersonation. When an attacker hijacks your MCP session, they get everything. I mean, they can issue command, get into your tools, pull sensitive data, and the whole time the system thinks it's you. It's complete takeover. So what's actually happening here? What's going under the hood? Well, with the Model Context Protocol, or MCP for short, a session gets created anytime your AI agent, like a plugin in your code, connects to a server. Think of this session as holding the keys to the kingdom, your authentication, your capabilities, all your tools. And here is the kicker. If an attacker manages to steal that active session, they completely bypass authentication. They don't need your API key or anything. They just walk right in the front door using all your permissions. To really get this, let's make it real. Let's walk through a scenario that's unfortunately all too realistic. We are going to follow a developer, we'll call her Sarah, and see just how easily a totally normal day at work can spiral into a huge security nightmare. So it all starts out as a completely normal day for Sarah, who is just doing her thing, working on her VS Code editor. She is using this really helpful extension that gives her AI-powered code search and file editing capabilities. This extension sets up an MCP session with a server that's running right there on her local machine. Super common, super powerful workflow, right? Okay, so the next step is something we all do probably 100 times a day, just browsing the web. Sarah clicks on a link to a documentation site, but what she doesn't know is that hidden on that page is a malicious script. And what's that script's one job? It immediately starts trying to connect to that local MCP server she has running. Now, this shouldn't happen, right? But this is the first big mistake. Her server is misconfigured. It's actually allowing anonymous connections. And this right here, this is the heist. This is where the actual theft happens. See, Sarah's Legit's extension stores its session token in her browser's local storage. Now, that's a pretty common thing to do, but it's also super insecure. The batch script on the website uses what's called a cross-site scripting or XSS exploit to basically just reach into the browser storage and snatch the token. And just like that, the attacker has the exact same session ID that Sarah's trusted editor is using. And yeah, it's pretty much game over at this point. With that stolen token in hand, the attacker connects directly to Sarah's MCP server. The server sees a valid session token, and what does it do? It lets them right in. No questions asked. It treats them as a fully trusted agent. The attacker is now, for all intents and purposes, Sarah's own ID extension. Meanwhile, Sarah finishes up her work, completely oblivious that her session has been totally hijacked. But while she was coding, the attacker was busy. They quietly modified one of her build scripts and slipped in a backdoor. So when Sarah deploys her application to the production, she's also deploying the attacker's malicious code. And think about what just happened. A temporary session hijack has just turned into a persistent long-term access to a critical production system. That's a huge problem. So what's the big payoff for the attacker? I mean, what do they actually get once they have pulled this off? Well, they pretty much got the keys to the kingdom. The level of access is just staggering. They can read any file that Sarah can. They can modify the source code. We saw them inject a backdoor into our example. They can run commands, dig into environment variables, and steal critical secrets and credentials. We are talking total absolute control. Okay, so we have seen just how devastating this can be, but the big question is, why did it even work? Let's break it down and really see what's happening under the hood. Let's break it down and really deconstruct the specific security failures that let this happen to Sarah so easily. This attack was really only possible because a whole chain of pretty common weaknesses all lined up just right. First off, that session token was stored insecurely in the browser's local storage. Big mistake. Second, the server was just letting anonymous reconnections happen. Third, the session wasn't bound to Sarah's specific client or her IP address, which meant the attacker could use it from anywhere in the world. And you add in a long lived session ID that never changes and a vulnerability to access it, and you have basically cooked up a perfect storm for a breach. All right, now for the most important part. We have seen the threat, we understood the weak spots. So, how do we actually defend against this? Let's open up the prevention playbook. This is all about a defense in depth strategy. You need multiple layers of security. So, start with the mutual authentication. That means the client and the server both have to prove who they are before they can exchange any messages. And this is a huge one. Never store session tokens in storage that the browsers can get to. You also got to rotate those tokens frequently and bind the sessions to the authenticated client so they can't be stolen and reused somewhere else. On top of that, you bring in the standard best practices. Encrypt all your traffic with TLS. Add cross-site request forgery or CSRF protections to block malicious requests. And of course, always use the principle of least privilege. So let's be really clear about this. MCP session hijacking isn't some theoretical what if kind of risk. It's real practical high impact threat that's happening out in the wild. If you are building any systems with MCP, this has to be on your security radar like right now. So I'm going to leave you with this one question to really think about. If an attacker hijacked your session and started issuing commands as your AI agent, would any of your systems even know the difference before it was too late? Think about it. Thank you.